Hello students, today we are going to study Standard 6 Physics, Chapter number 3, Physical Quantities and Measurement. Measurement is a part of almost every aspect of our day-to-day life, isn't it? If you go to the market to buy vegetable and if the vegetable seller if he gives you suppose tomato without weighing it, and he asks that this is 2 kg and you take the tomato and give me suppose whatever price, suppose 50 rupees. So would you like to buy that tomato without weighing it? No, of course not, isn't it? You want to know that whether the tomato that you have brought that is exactly 2 kg or not. So just in the same way, when you want to measure the length of cloth, if you want to buy the cloth, when you go to the cloth merchant to buy the cloth, so you tell him to measure the cloth. After that you pay accordingly. But if the cloth merchant, if he gives you the cloth without measuring the length of the cloth to you, would you like to pay the person whatever he asks? No, of course not. So in our day-to-day life, we come across various circumstances in which we need to know the correct measurement of the substances. Any quantity that can be measured is called the physical quantity. Just children, can you tell me what are the substances that can be measured? What are the quantity that can be measured? We generally measure mass, length, time, temperature, etc. So the quantities that can be measured, they are called the physical quantity. When we talk of the physical quantity is of two types: fundamental physical quantity and the derived physical quantity. Fundamental or the basic physical quantities that do not depend upon the other quantities. Okay, for example, physical quantities such as length, mass, time, okay, these are called the fundamental physical quantity. Derived physical quantities are those physical quantity that are derived from one or more fundamental physical quantity. Okay, for example, in order to find the area, we need to multiply length and breadth. So length and breadth can be said as the fundamental physical quantity, but the area which we find out from the length and the breadth, that's called the derived physical quantity. In the same way, suppose when you are finding the density means mass by volume. Mass, okay, it is a fundamental physical quantity. Volume, it is one of the derived physical quantity. So just the derived physical quantity, we can say that it is derived from the fundamental physical quantity. Derived from fundamental physical quantity. For measuring any physical quantity, we need to know its unit. Okay, for example, when we measure the length of any article, for example, one book, suppose the length of the book is 20 centimeter. Okay, then 20, it is called the magnitude and centimeter is its unit. Okay, in the olden days, when no system of unit was developed, during that time there was traditional unit such as it was not traditional unit, it was traditionally it was the body parts was used for measuring the natural surrounding, we can say. For example, handspan, one handspan, okay, a handspan, then we can say one cubit, okay, cubit for measuring the cloth, okay, or the hand span, palm also, finger, okay, it was used for measuring different length. But you know, the length of the hand span or the cubit, it may differ from person to person. A person who is very tall, his hands may be longer than the one who is short. Okay, so it is not a standard unit. It is not. So in order to get a proper measurement, we need to have a standard unit, okay, because the traditional units were not uniform, okay, just like hand span or the cubit, okay, it may vary from person to person or according to the body size. Okay, so when the time passed, according to the time, and people felt that there is a need to have a standard unit. So in 1791, um, the French Academy of Science developed a system of measurement, okay, which was not only simple but also scientific, and this system was known as metric system. And with the passage of time, metric system gave rise to two variants, that is the CGS system and the MKS system. From CGS you can understand centimeter, gram, second, and MKS meter, kilogram, second. You know, but the existence of this CGS and the MKS system again led to the need of interconversion between them by the users. Okay, so in 1960 there was a general conference of weight and measure in Paris. Okay, and there they adopted an international system of unit which was known as SI system. Okay, Standard International System. In SI system, we have the multiples and submultiples of units. For example, I can say that centimeter, okay, it is a submultiple of kilometer. Okay now, and we can say like kilometer is the multiple unit of meter. Okay, that is the smaller one, smaller form, I can say it as submultiple, and the bigger form I can see it as multiple. Okay, like 1 kilometer is equal to 1000 meter, then I can say kilometer is the multiple unit and meter is the submultiple unit. The smaller unit is called the submultiple unit. If I say suppose 1 quintal is equal to 100 kg, so kg here it will be then submultiple unit and quintal will be the multiple unit. Is that clear? There are certain guidelines for writing the SI unit correctly. Okay, unit is generally written in small letter like meter, METRE, that M should not be capital, M will be small letter. Okay, in the same way when we write for time, when we write second will be in small, S will be in small letter, not in capital letter. Okay, and if a unit is derived from the name of a person, then its name is always written in small letter, not capital letter. Like Newton, when you write Newton, 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 the N should be small there, not capital. Okay, symbol of Newton will be capital N. That's another thing. The symbol of this unit is like Newton when we write capital N, but the full when we write Newton, so their N will be small letter. In the same way, suppose when we are writing ampere, the unit of current, electric current, ampere, 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 the letter A will be small, but when we are writing the symbol of that unit, we'll write for ampere, we'll write capital A, not small a. Okay.